Okay, ladies and gentlemen, we are going to kick off a new unit with this video, and it's going to be about square roots and inverses. But before that, we're going to do a little background and talk about function notation and operations on functions, because this is necessary to go on in this unit. So let's first start with function notation, what that means. You have probably heard by this point of f of x, okay? And the reason you need f of x is if you start talking about multiple functions in one situation, in one problem, you need to be able to refer to them by name, and if they're both named y, then that doesn't help us very much. So f of x, basically it's the same thing as y. It's a function of x, but it gives us that name of the independent variable of x is in the name, so we know what f depends on. That's not really the reason for it, but that's just what the x is doing there. Everything else is the same. We just call it f of x instead of y. Okay, so there's one function. If we have another function, normally they'll call it g. It could be called anything. But this is called function notation, f of x and g of x. They're both the same as y. They're both the dependent variable. They're both the vertical axis on a graph, but it's just a new kind of more advanced way, and it's helpful when we start to put functions together. All right, so what can we do with these two, the operations? Basically, you need to know how to add, subtract, multiply, and divide functions, and then make composite functions, which we'll talk about in just a minute. So first thing you need to be able to do is add. Now, the notation can be a couple, you could see it in a couple of ways. F plus g of x is one way to write it, which just means add the two things together. It could be just written, I prefer it like this myself, but they didn't consult me. F plus g of x or f of x plus g of x just means add the two together. So in this case, we would get x squared minus 7x plus x, that'd be minus 6x plus 6. Just added the two together, combined like terms, to get f plus g of x. I'll leave those there. All right, so subtracting, same deal. F minus g of x, or f of x minus g of x. It's going to be the first minus the second. I'm going to get x squared minus 7x plus 2 minus, make sure you subtract the entire second function. So that negative is going to distribute, and we'll get x squared minus 8x minus 2. All right, so nothing big here. When you learn about polynomials, you combine like terms, so we haven't really done anything different than that yet. F times g, because we're going to add, subtract, multiply, and divide. So you could write that f times g, or you just write them like that. You could put a dot in between the little dot for multiply. So let's see, I've forgotten my functions. X squared minus 7x plus 2. And then x plus 4. Okay, so for the sake of time, I'm going to pause for a minute. I would encourage you to multiply that out. Pause your video, multiply. Be back. Okay, so that's that multiplied out. I just distribute each of these terms to each of those terms. What I did there below is just kind of group them by like terms as I went. It's just one way to multiply them out. You don't have to do that, but you should know that the two multiplied together give you that. All right, so division. There's really, depending on the situation, not a lot you can do. Division, we'll write it like f over g of x, or, of course, like that. And we're just going to put, f over top of g. There's not Depending, you might be able to factor and cancel, but this one's going to just equal x squared minus 7x plus 2 over x plus 4. And sometimes when you put them together like this, you will need to make a restriction on the domain. Remember, domain is all of the x's that you're allowed to substitute in, and whenever you have denominators, you create the possibility of needing a new domain. And in this case, all x's are okay except negative 4, because that negative 4 would make a 0 in the denominator, and that's a no-no. So other than just writing one on top of the other, I need to make that little domain correction, and then that's it. Okay, so we haven't really done much yet. Let's talk about this function calls first. So just a reminder, so I don't have to keep scrolling. F of x is x squared minus 7x plus 2. What is f of 2? All right. If you write f of 2, what you're saying is let x be equal to 2. Evaluate this function at x equals 2. Which means every single x in the function needs to be changed to a 2. So I get 4 minus 14, which is negative 10, plus 2 is negative 8. So that's what we call f of 2. Subbing in a 2 is not that complicated. Sometimes when we start to sub in other things, like x minus 3, people start to struggle in this case, okay? Whatever goes in these parentheses right here needs to get put in place of that x and that x, and it needs to happen in the set of parentheses. So f of x minus 3 is x minus 3 squared minus 7 times parentheses x minus 3 plus 2. Okay, and it might seem easy and logical in this example, but year after year in many different classes, function calls of, more than just subbing in a 2, like subbing in an x minus 3, cause problems. So be careful with this and make sure you understand it. Whatever goes in those parentheses is going in for every single x. So then I would have to multiply this out. Again, I'm going to pause for the sake of time. I encourage you to pause, multiply this out, and then we'll compare answers. Okay, so unless I've got a arithmetic mistake, our answer for f of x minus 3 is x squared minus 13x plus 32. A couple of things to point out. Make sure that you never square that and square that. Again, I say that because I've seen it happen a million times. Each time it turns another one of my hairs gray. Do not distribute a square. Write it twice and multiply it out. Secondly, make sure that that negative is included with the 7 when you distribute. Negative 7x, positive 21. That would be the two errors I would expect, if any. All right, so that's f of x minus 3. This is just a function call where we substituted in x minus 3. And you need to know how to do that for things that are coming soon. All right, so now let's get to composite functions. And this is written as f little circle g of x. That's one way to write it. That is pronounced f of g of x. And I prefer f of g of x. But again, if you see that little o, that's just of. It's just shorthand for of f of g of x. F of g of x. Okay, so our functions were x squared minus 7x plus 2. And should be able to remember this by now. X plus 4. Okay, so what does f of g of x mean? Remember, whatever gets put in these parentheses needs to go in for x here and here. established that earlier. So f of g of x would be something squared. That first x gets squared. And what are we substituting in for that? G of x. And what's g of x? X plus 4. Okay, so x plus 4 squared minus 7 times x plus 4 plus 2. So when we did f of x minus 3 a minute ago, this is the same. It's just that we had to figure out what to sub in, and that was a different function, g of x. Okay, so make sure you understand f of g of x. It's a new function that's created by taking g and substituting it in here and here. All right, so let's multiply this thing out. Never distribute a square. Contribute to my hair turning gray. Write it twice. FOIL it out if that's the method you prefer. Distribute both x squared plus 8x, which was plus 4x and plus 4x, plus 16 minus 7x minus 28 plus 2. And then gather your like terms. X squared 8x minus 7x is 1x. And 16 minus 28 plus 2 would be 18 minus 28. It's like negative 10, I think. So there you go. That's f of g of x. So what's f of g of 3? Well, take f of g of x and substitute in 3 for x. 3 squared plus 3 minus 10. That's 9 plus 3 is 12 minus 10 is 2. So that's how you would do something like f of g of 3. You could do f of g of x plus 1, where you would substitute into one and substitute in the other. And it's sometimes are called nested functions. You could have one within another within another. It could go several layers. But for right now, just make sure you understand whatever goes in the parentheses is getting substituted in for x. All right, and that's going to do it for this. You need to know how to take two functions and do different operations, substituting one in for the other, add, subtract, multiply, divide. And this will be a good start for our unit on radicals and inverses. Young out.